This video is going to be a short video on calculating the standard deviation of really big amounts of data. The data from that 10 million point data file and the 1 million data point file. We're going to do that today. The program we're going to do is very similar to the average_big program, so that's our starting point. We're going to start with that folder, go to File Manager, find that folder, make a copy of it, and then change the name to stdev_big. You go into that folder, we erase the executable, and rename average_big.c to be stdev_big.c. We double click on it, and it comes up in Notepad++, and we're ready to start. First thing we have to do is you have to add the math.h because we're going to do math, right? So we do hashtag include math.h up at the top, right there with the other hashtag include statements. And we have to add a variable for the sample standard deviation, s. So, and you have to make it a double because we're dealing with really big data sets. So we say double space s and then semicolon up there at the top. That's all we have to do for the top. When we calculated with standard deviation, we had an array, a, and we used a sub I for both calculating the average and calculating the sum of the squared differences after you calculated the average, those two for loops. We don't have that in this. We use temp to calculate the average. We didn't store the array values. We just grabbed them from the file. That's the trick that I wanted to teach in this video is sometimes with really big data sets, you don't store it in the working memory of your program. Just use the file every time you need to get the data. And so that's what this is. The first loop there is a while loop, while fscanf. We find out how many points there are in. And then so we take a second loop where we say sum equals 0. And then it's a for loop, for I equals 0, I less than n, I plus plus. And in that for loop, then we do the fscanf percent fp. We have to reopen the file. So we close the file, then we reopen it. Then we do this for loop. And we do the fscanf statement inside that for loop. We know how many points there are because we found it in the first loop. And then we do the sum equals sum plus, and then the POW version from the last stdev program that we did inside that for loop. Again, we just use temp, so it's temp minus average to the square power, not a sub I. And then at the end of that loop, we reclose the file again. So we open the file, we calculate the average, we close the file. We reopen the file, we calculate some of the square differences, then we close the file. So using the file as the repository for big data, for lots of data, that's not an uncommon data strategy. It's just one of many tricks. A real live computational person has even more tricks, direct memory access, and there's zillions of different things to learn in that regard. This is just the step one. This is just step one in thinking about using a file as as the place where you actually extract your data from. We made those changes. You can see all the changes that we made there, and then I go into the command prompt. I search CMD, and up comes command prompt. I double click on that. I CD into OneDrive, CD into desktop, CD into C code, and then I CD into my stdev_big. I compile the program, and I'm going to run it with the 010.txt to see if I get the right number, and I do, and then I run it for 01 million and 010 million. I can't do that. I can't compare those numbers with what Excel or some other off the shelf package could do. I know it's the right answer because I made all these O files are random numbers using a pseudorandom number generator, and so the standard deviation is going to be about the same for each of them, and you can see that it's the case, and that's always been the case. So that's my little check to make sure that the code works right. That's it. That's the one trick we learned is reopening a file and re-accessing the data to calculate the standard deviation of really big numbers.